So this is my lab report for Lab 1 on charge tapes. And these are the sections that are included in my lab report. And it is important to note that rubbing, pulling apart, or touching another object can cause an object to have an excess charge, which can be either positive or negative. Also, ordinary matter is electrically neutral, but removing or adding charged particles gives an object a non-zero net charge. And also, electric force is proportional to the amounts of both charges. And the problem statement for this lab was to determine how much excess charge is on a piece of charged tape. And we found it to be 9.94 times 10 to the 10th excess electrons on tape B. The lab procedure included quickly pulling apart two pieces of neutral tape, bringing a hand towards a piece of U-tape, bringing two U-tapes close to each other, bringing one U-tape near a neutral object, rubbing a clear plastic pen on a cloth, and bringing the pen near U-tape, and putting one U-tape above another. Some of the observations I made in this lab were that when two pieces of tape were quickly pulled apart, the base tape becomes positive and the U-tape becomes negative. Bringing my hand towards the U-tape resulted in attraction between my hand and the U-tape. And when a pen is rubbed on cloth, the pen becomes negative, and then bringing the pen near the U-tape results in repulsion between the pen and the U-tape, which shows that the U-tape is negatively charged. Some of the underlying principles for this lab were that the change in momentum divided by the change in time was equal to 0 for tape B, and so from that we know that the net force is equal to 0, so we could say that the sum of the forces in the y direction equals 0, which means that the magnitude of the gravitational force on tape B is equal to the magnitude of the electric force due to tape A. Here's my code, and in this code it's important to note that the charge is equal to 1.5903 times 10 to the negative 8 coulombs, and it's also important to see that the magnitude of the electric force is equal to the magnitude of the gravitational force, as indicated by the red arrows. My calculations for part A involved finding the mass of one piece of tape, which is equal to 0.00016 kilograms, and finding the magnitude of the gravitational force on tape B, which is 0.001568 newtons. My assumptions for the lab were that each U-tape has the same net charge, which is evenly distributed along the length of the tape. I also treated each tape as though it were a point charge with all of its charge located at a single point at the center of the tape, and I ignored air resistance on a moving object. So these assumptions allowed me to resemble the two pieces of tape as one point charge floating above another point charge, which is represented in figure 6. My calculations for part 2 involve measuring the separation distance at which the tape B begins to float above tape A, and I found this distance to be 0.0381 meters, and then I was able to find the amount of charge on tape B, which was 1.59 times 10 to the negative 8 coulombs, and then I calculated the number of electrons on tape B, which was 9.94 times 10 to the 10th excess electrons. And then my calculations for part 2 also included finding the length of one piece of tape, the area of one piece of tape, and then the area of an atom, and then I was able to calculate the number of atoms on the sticky surface of the tape, which was 4.851 times 10 to the 17th atoms, and then I found the fraction of atoms that gave up electrons, and this was equal to 2.05 times 10 to the negative 7th atoms. So some discussion questions from this lab were, what if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? So the U-tape would be positively charged on its lower surface, and the base tape would be negatively charged on its upper surface. And the U-tape and pen would be attracted to each other, since the rubbed pen is negatively charged. And also, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? The charged tape causes an electric field and induced dipoles to become present inside your hand. The dipoles create an electric field at the location of the tape, which attracts the tape. Thus, there would be a transfer of charge from the tape to the initially neutral object. And finally, in conclusion, ordinary objects can acquire an excess or deficiency of negative charge if they are rubbed, pulled apart, or touch other objects. And the purpose of this experiment was to determine the amount of excess charge on a piece of tape.